Good morning, good afternoon, or good evening, depending on where you are, and welcome to today's DevOps.com and Security Boulevard webinar, brought to you by TechStrong and BluBracket. My name is Cody J. Brown, and I'm the host of TechStrong Learning. We have an exciting panel ahead, but before we begin, I have just a few housekeeping notes. First, today's session is being recorded, so if you miss any of the talk or you would just like to share it with a friend, the on-demand will be made available after the webinar concludes. If you look on the right side of your screen, you'll see a Q&A tab. This is where we want you to send in any questions that you might have for our speakers today. If you'll look next to that, you'll find the chat tab, and this is where we want you to add to our conversation. If you have any comments or concerns, anything that you just want to include to further our conversation, that's going to be the best place to do so. And finally, at the conclusion of our webinar today, we will have a drawing for 4 $25 Amazon gift cards, so stick around. So on to our topic today. We're going to discuss eliminating security gaps in the software supply chain, a collaborative approach. And I'm joined today by Ajay Arora, President, COO, and co-founder of BluBracket, Inc., Jim Zemlin, Executive Director of the Linux Foundation, and Randall Deggs, Head of Developer Relations and Community at Snyk, Inc. And it is my pleasure at this point in time to turn the floor over to Ajay to get our conversation started. Ajay, thank you for being here with us today.
Awesome. Thank you so much, Cody. And thanks to the attendees and to the presenters for us here today, and looking forward to the topic that we have. I think we're going to have a great panel here. So just to kick things off, I'm Ajay Arora. I'm one of the founders here at BluBracket. We're a company that focuses heavily on eliminating risks in code, especially as it affects or helps in software supply chain security. And software supply chain security is one of these new buzzwords that we're going to dive into a lot today, and really get deep into the subject and really talk about what it is and understanding it. I think once we go over what is some of the key learnings that we want to impart today, you'll understand why our speakers are well suited to be able to handle the subject right. So number one, we're going to really try to focus on understanding why the software supply chain is such a powerful threat vector for businesses and otherwise, and then get into some of the key risks in the software supply chain and how to eliminate them. Of course, that's after we actually define what the software supply chain is. Who's actually responsible for supply chain security in your companies or at large, and then get really specific also as to what role does open source software and vulnerabilities in source code play in securing the software supply chain. So that's really what we want to cover in the next 40 odd minutes or so. And then we're going to open it up to questions that we're more than happy to answer. So with that, I'm going to allow our presenters to introduce themselves. So I'll start off with Jim Zemlin, who's the Executive Director of the Linux Foundation. If you don't mind, please doing a quick introduction.
Hi, everybody. My name is Jim Zemlin. I am the Executive Director, as Ajay mentions, of the Linux Foundation. We're obviously home to an array of critical open source projects, most notably Linux. But we also work in the security space. Most recently, we have an effort called the Open Source Security Foundation, which is made up of organizations from the tech industry that are working collectively to shore up weak points in the open source software supply chain as it relates to security.
Awesome, Jim. Thanks so much. Randall, if you don't mind doing a quick intro as well.
Yeah, hey everyone. Super nice to see all of you. I'm Randall. I work at a little company called Snyk, and we're a developer security company. So we basically just build tools for developers, DevOps, and security practitioners to help you build more secure software. I'm a software developer myself and a security person. I do a lot of open source work, and yeah, I just love building developer tools. So thanks for having me.
Yeah, of course. Thank you so much for joining, guys. So why don't we go ahead and dive right in? And Jim, maybe if you can, as I opened up with, there's been a lot of buzz around what exactly the software supply chain is, number one, and then maybe you can comment on your perspective on why it's become such a powerful and ever-present, in some cases, people think an existential threat to organizations to governments and into everything at large, since software seems to power everything every day nowadays. So I'd love to get your perspective, and then would love to hear from Randall on that as well.
Yeah, so software has a distribution mechanism similar to how hard goods are distributed around the world, at different ports and through different standards around transportation and so forth. In the case of software, however, all of that happens nearly instantaneously, based on the fact that code can travel from one point to another at the speed of the internet, essentially. I think it's important when you think about the software supply chain to have a basic understanding of how code flows throughout the ecosystem till it gets to you as an end user of that software. Today, software is made up of thousands of different components and building blocks, much of that open source, some of it proprietary as well, that starts with a developer creating that software in a variety of different version control systems, the most prominent of which is GitHub, but there are also a lot of critical open source projects in communities such as GitLab and in older source control systems as well. That code then flows into a build system. Those build systems often bring in dependencies. Think of dependencies as different additional building blocks of code that are distributed through package management systems. That software then comes together and it is eventually delivered and implemented as a software service or as any technology product or service that we all consume every day as we go about our daily lives, which, as you pointed out, Ajay, are heavily influenced by software. At each point in this distribution cycle, there are places where there are security weaknesses that attackers can exploit in order to do bad stuff. Those things can be at the developer level, things like bypassed code review, compromised source control systems, poor coding practices, unrealized bugs. Code can be modified after the source control system. We can see packages that are dependencies that can be hijacked. We see the use of bad dependencies, particularly in the JavaScript community. We can see bypassed CI/CD systems, a outright compromised package repository, and so on and so forth. So at specific points in the software development and distribution process, I think the most important thing that we collectively can consider is how to shore up weaknesses. And we can talk about how at each of those points we have work going on at the Linux Foundation and how we're working with the broader open source community to shore up those weak spots.
That's wonderful. So Randall, would love to get your perspective on this as well, in terms of how Sneak looks at the software supply chain. And then maybe you can also comment, maybe you both can also comment on this, is that we never talked about software supply chains before. I mean, software's been around forever, but this seems to be a relatively new term. Why is this term emerged now versus 20 years ago? What's changed from that perspective? Randall, would love to get your views on the definition and that topic as well.
Well, I think Jim did a much better job articulating it than I'm going to. But basically, I always think of software supply chains just software dependencies. Like, what are all the dependencies that you need to build and run your applications? You've got databases, actual source code, your actual code dependencies, open source libraries you import into your project, just all the things that make it possible to do, to build software. And, I think the word supply chain in my mind is actually a little bit inflated, especially just recently during the pandemic, because we hear about all these supply chain issues around the world, And so I think it's a little easy to visualize it when you think of it that way, as, some big stores having supply chain issues because their distributor in another country has a lot of people sick and can't go into work, and then shipping is slowed down and all these different things. It's really the same issue with software. Sometimes you have issues and bottlenecks and security problems at any of these different points. And it's really important to be able to identify those things first, and then secondly, address them in a reasonable way. And yeah, that's my TLDR of supply chain.
Yeah, no, that makes sense. Jim, any comments as to why this has become so much more prevalent now versus like a 10,
I mean,
15 years ago? Yeah.
Speak for yourself, because I've been using the supply chain security term for quite some time now. But the Linux Foundation tends to be a little ahead of the curve on that one. I do think Randall's right that the term, sort of using supply chain as a catch-all to help us improve the baseline for software security in general, I think is a helpful way, because you have to it just like physical security, just like hardware security, where there are very robust systems to protect the provenance of hardware and physical things. In the software world, where there are similar distribution systems, we haven't taken the security of those things as seriously, perhaps. And then I just think, the generic term supply chain issues can often be used as any sort of excuse. For example, I forgot my wife's birthday the other day due to supply chain issues, and wasn't sympathetic with that, but I try.
It looks like the supply chain is getting blamed for everything. So nowadays, so I'll have to keep that one in mind as well. So I guess what we're also saying here, I think I'll just give our perspective a little bit as well. Seems like we've definitely shifted from this world where it used to be that people kind of built their software from the ground up, and they would only trust software that was built internally. Then we added third-party components from partners, and now maybe Jim, you can tell me much better than I would know, or Randall can tell me. It seems like no one starts with a blank slate anymore at all, right? So there is this inherent connection between open source and supply chain security. So from that perspective, right? I think the elephant in the room that's out there right now that everyone's been talking about, that's brought this to the forefront, is Log4j, right? So maybe Jim, you can talk for a second on first of all, what is the Log4j supply chain vulnerability? And what's that done to bring this open source in the supply chain security to the forefront? And other anecdotes that you've probably known about for quite some time, and Randall has.
Yeah, I think the important thing to understand is that all software has vulnerabilities that are exploited as attack vectors for people who want to do bad things. So whether it's proprietary software or open source software, it's similar. The issue around open source software starts with Log4j, which is a very widely dependent upon logging system that's used by a lot of folks. Had a vulnerability that was particularly problematic in that it sort of opened up people's systems as a major attack vector, essentially left the door open for people to come in and maliciously do things. It's turning out in retrospect that it wasn't as widely exploited as we had maybe initially believed, but it was a horrible vulnerability nonetheless. This follows a few other, highly visible open source security issues, Heartbleed probably being one of the most notable years ago. This was a critical vulnerability in OpenSSL, that little lockbox in your web browser. Another Apache project, Apache Struts, was connected to an issue around security for people's financial records, and so on and so forth. The main issue here is that you have the goodness of open source. The reason that people use open source as fundamental building blocks for any modern product or technology product or service these days is because code is extremely complex, and to write all of that by yourself would be insane. So what open source has really provided is billions and billions of dollars worth of freely available reusable components that anyone can use, that anyone can participate in improving, to build the fundamental software technology that we all depend upon, whether it's a banking system, all the major components of the internet, cloud services, and so forth. All of this stuff is inextricably and irreversibly built using open source. So the main question, if these open source projects, these different components, will inevitably have vulnerabilities, how can we, one, identify the most widely used components, such as Log4j? Two, how can we figure out who is working on those and whether or not that code is secure? And then how do we measure on an ongoing basis the security health of those critical open source projects in order to reduce the number of Log4js and try and get ahead of needing to react to those? I would also add that we in the open source community can also create better traceability of these different software components in order to more quickly remediate Log4j type issues. Because today, attackers are not waiting days and weeks to exploit these vulnerabilities. It's minutes and hours, which is exactly what we saw with Log4j. So that's really where our organization is focused, is understanding what those critical projects are, providing them with training, tools, and help to improve the baseline for their security, and then doing that for a very broad set of open source components so that we can all get the benefit of that billions and billions of dollars worth of fundamental building blocks and have that also be trusted based on a higher bar for secure coding practices, software distribution, and so forth.
Wonderful, wonderful. So Randall, from your perspective, you shared with us a really interesting stat prior to the call. You said about 32, Snyk has identified 32% of all open source projects that you guys have seen have identified vulnerabilities. So how is this, first of all, maybe you can comment on that around that statistics and how you've seen that potentially grow. But what's a developer or a development organization or an enterprise to do? It seems like this is kind of a tsunami that's only building, especially as open source and other components become more prevalent. And the other thing I would highlight is that inherently in your discussion too, it seems like there's a large amount of components that are related to like what I'll call an external supply chain, so to speak, versus an internal supply chain versus what you're building internally. So maybe you could comment on what you've seen in terms of the growth of these kind of vulnerabilities, what kind of vulnerabilities they are, and what do we do about it, right, from that perspective?
Yeah, I mean, so in regards to the stats, so this is actually just from 1 week worth of data. So just the open source projects that Snyk, like new open source projects that we scanned over the past week, 32% of them had identified vulnerabilities. That number is actually artificially low though, because the real number is much greater. A lot of the projects that we're talking about here are projects that actually have no external dependencies whatsoever. It's much more common when projects have a number of external dependencies that there's going to be a large number of vulnerabilities somewhere. Now, they're probably very low significance, like not critical vulnerabilities or anything like that. But I think one of the important things people should know if they're listening to this is that, vulnerabilities will always be there. Like you're never going to have like perfectly secure software. You can do a lot of things to make software more secure. But I think the more important thing people should take away from this entire thing is that it's really just a process that you need to implement and instrument somewhere in your organization, in your personal projects, et cetera. And it's much more important to be able to identify issues when they come up and just address them quickly, and that's why it's really important to have good tooling, good processes, and good people to sort of help drive that type of security consciousness is what I would call it.
Yeah, so actually that's a great segue into a question that comes up a lot. There's been a lot of talk in industry and beyond, and I think Snyk has really pioneered this, is this whole concept of shifting left in terms of security and taking care of security problems. Can you maybe give a definition about what that means in terms of security? And how and why do you recommend dev teams and security teams achieve this from that perspective? So what does it mean to shift left?
So
how do you effectively do it, etc.?
Yeah, in that picture you have on the screen, actually, I think it's really good. So like, basically you have like the software development lifecycle. Some people abbreviate it the SDLC or whatever. But basically all it is you're a developer, right? Let's just say you're building a project solo. So you like, work on an MVP, you write some code, you check it into GitHub, you put it into a CI/CD pipeline, potentially, hopefully, you deploy it somewhere. Then you have testing and monitoring and reviews and things like that. That entire process from start to finish is the software development lifecycle, and parts of it are repeated all the time. Like you're always going to go back and like add new features and do more development. Then you're always going to test it usually. Then you're going to deploy it again. Then you're going to monitor it and stuff. And so what shift left means is that developers are getting involved much earlier in the cycle than they used to be. So historically, like especially as it relates to security, the way that security worked at organizations and projects is that developers wouldn't think about security at all. Like we would just build an application and then hand it off to like an operations team, for example. And the operations team would like package it up and do a deployment. And then the security team would sort of monitor things like asynchronously and then, get angry with people and say like, hey, developer, you have this problem. You need to go fix it. And so all of these groups were somewhat disconnected. And nowadays, because of just the democratization of a lot of these tools and techniques, it's easier for developers to catch things earlier on in that software development lifecycle. So nowadays, using tools like Snyk, like BluBracket, like all of these different things that are out there, and including lots of great open source solutions, as a developer, when you're actually writing the code, even in your IDE plugins, you can catch a lot of these issues early on. And that's what we mean by shifting left. Like, how do you take all of these concepts and all these things you need to do and just incorporate them into your normal development workflow so that your life is just way easier? And yeah, that's the gist of it.
Yeah. So Jim, I mean, let me ask you this question. So we're already asking developers to do a lot. I mean, people are heavily measured on shipping code, and now we're piling on this whole piece of security onto their plate as well. I mean, if you look at things that have shifted left, so to speak, QA has shifted left, infrastructure as code has shifted left, and now we're putting the onus of security on developers as well. I mean, the mantra, good or bad, for a long time in the Valley has been, build fast and break things, and we'll figure out the rest. That obviously has changed a lot. So how do we not break the back of developers and able to do this? Can you talk about maybe some key things that we can do to make it easier for developers?
Sure.
And also, I mean, people do what they're measured on to do, correct? So how do we make it in their best interest to worry about security and build these in early?
Well, actually, wait, before you answer that, Jim, it looks like Robin in the chat had a question that like perfectly ties into this. I'm just going to read her question off real fast and let's scope it towards that. So what Robin said is, what processes would you suggest be put in place or are already in place to protect against open source code being impacted with persons leaving current positions or a disgruntled employee deleting code, maybe even accidentally? Do you have backups in place to prevent this sort of impact? And I think this is a really good question because it ties in super well to what we're talking about. So maybe Jim, like you could give an answer to Robin.
Sure. I mean, I agree with Ajay in that the emphasis has traditionally been on, shipping features, and there's certainly a big amount of pressure in any proprietary open source software to do such. The difference today is that software is a part of our daily lives. And if we can't trust that software, nobody's going to use it anyway. So, I don't know why you would bother writing it, because if you write insecure code, people won't trust it, they won't use it, and you'll just be sort of spitting in the wind. I think the good news is that we have some examples of where developer focus and sort of a shift left in the software development process has been quite effective. And this comes from, ironically, Microsoft, which I spent the better part of my career criticizing for other reasons than software security. But in 2004, Bill Gates wrote a letter to one of his famous letters to all of the Microsoft staff and said, we are going to stop all software development. We are going to institute more comprehensive testing, threat modeling. We're going to go through and audit our code bases. We're going to have processes like Bug Tuesdays, which still exist to this day. And we're really going to do what we're describing here, which is sort of shift left in the software development process, the security. And it was pretty effective. Now, that's not to say that Microsoft software doesn't still have vulnerabilities. Like there were a couple last week that were pretty significant and are being remediated. But what's important to understand is that kind of thought really can work. The difference in a non-hierarchical open source community is that there is no command and control. In other words, Bill Gates certainly would have had it in his power to fire anybody who didn't comply with secure coding practices at Microsoft, and had mandatory processes that were used across the entire company. You can't do that in open source. You can't go out and fire 800,000 developers. What we need to do in open source is rebuild trust. And that trust can be rebuilt by creating a culture of secure coding practices that is important, given the role that open source now plays in society, and creating better reputation systems that will incent people to create better code. In addition to that, I think developers need a helping hand. One of the things that we're looking at the Linux Foundation is identifying at least the top 200 most critical open source projects out there, of which Log4j, I think, is number 27. And going and providing them with meaningful assistance, helping them audit their code via third-party audit services, providing them with testing tools and reputation systems. I just put into the chat a link to our security framework that has a scorecard that you can look at. It's, we use Sneak and BluBracket and really any secure coding tool in order to help developers better test their code, better measure the results of those tests, better track the remediation of vulnerability, to be able to look at whether or not they've passed secure coding best practices, such as our Open Source Security Foundation's best practices, even finding offensive language in code. Through these reputation-based systems, we can create much better trust, and we can reward developers, and in the case of the most critical projects, provide them with help, with engineering resources, with testing, with tooling, with training, in order to try and get ahead of the next Log4j. So that's really where we're looking at the Linux Foundation, is to provide that helping hand.
Wonderful. Hey, Randall, a question for you. So you're kind of at the eye of the storm at Sneak when it comes to engaging and working with developers. This is especially, I've been in security for a long time, and it's really refreshing to finally have someone who's responsible. Everyone's responsible for obviously working with developers, but to really bring it to the level of recognition in security, Sneak has been pioneer at doing this. What's the reception been with developers in terms of wanting to get ahead of these security problems? I mean, there's some statistics that say that it's 60 times more expensive to find and risky to find risks and vulnerabilities in code that leak out into production versus stuffing them out early. What's been the reception from developers in wanting to do this early?
That's an extremely good question. I'm going to share my raw, unfiltered personal opinion on this. Okay. So my background is I've been a developer for a long time, and I got my start doing security development on like Unix-based operating systems, like low-level work, and then eventually worked my way up to doing like web security, authentication, things like that. But in my personal opinion, security is really boring. Like, I've been in the industry forever. I think it's cool, but at the same time, it's, a lot of the time it's thought of as like an academic subject. It's sort of complicated. I think in the developer world in particular, people are oftentimes, they just don't want to have anything to do with it. They're like, look, I get it as a developer. Like, you want to build things and you want to have fun, like getting features out the door and creating, because it's so addictive to do that. But then when you run into problems that require you to slow down, like fixing some vulnerability or even identifying or thinking about these other things, it just feels like a bit of a hassle, to be frank. And so I think that the proper way, like just generally speaking here, to help build more secure applications is to just make security like a part of the default tool set that people have access to. I think that's one of the really cool things that Jim and the Linux Foundation have been doing with their new like OpenSSF project, is like, how do we build tools that the community has access to that can just democratize security for people? And you know, I think a really good example of this, at least in my career, is watching like unit testing and like continuous integration and deployment pipelines become widely adopted, and watching the tooling become ubiquitous. Like when I got started developing in the early 2000s, you know, those things were already in existence, but it wasn't really easy to build a continuous integration pipeline or to do continuous deployment. Like it was really difficult. I remember when I was running my startup like a really long time ago, I was deploying everything to like Rackspace, and Puppet was really new at the time. And I was writing like configuration management rules to like build my infrastructure and like SCP files from like my laptop over to like these production instances and try to keep everything organized. It was just really hard. And now today you have like GitHub Actions that like anyone can use. You have tools like Heroku and AWS and Elastic Beanstalk and all these great things. They've just made it like almost brainless, right? To instrument these pipelines. And so the way I see the industry going is it's no longer the security team's job to do a good job at security. It's becoming more of a development just responsibility that is just part of the normal development lifecycle. And I think as the tools continue to mature and evolve, like hopefully it'll just be an easy thing that developers just recognize. Like I can totally see a world where every time I type git commit, there's like a pre-commit hook that runs on my laptop, which is notifying me and saying, hey, Randall, you're about to commit this code. We stopped you from doing it because this like commit you just added is adding in this version of this software library that has a remote code exploit embedded in it. And like, it's going to like screw you over. Right. So yeah, that's a long-winded way of answering your question, but hopefully that makes sense.
Yeah, no, it makes a lot of sense. I think the idea is that if you can make it as part of the ethos of people don't want to break the build, make it as easy for them not to break things or introduce vulnerabilities. Everyone, most part, want to be good citizens, right? I think our job as security professionals to not make it boring and also to make it easy. So I think that's a great explanation. So shifting gears a little bit, trying to maybe summarize a couple of these key risks in the supply chain. So some people say nothing's actually real in the enterprise until Gartner has a view on it, or analysts have a view on it. So there has been a lot of discussion in trying to categorize some of these risks and some of these we've been talking about. So a couple questions that arise here. If you look at the kind of conventional wisdom that's forming, and if we have to get into recommendations of what risks to look at the different parts of the supply chain, I have a couple questions. One is like, what's your view, Jim, on this at a high level? If people were able to tackle these kind of risks, would they be 50% of the way there, 70, 90% of the way there? Are people taking, the other side of this is that, are people now taking these risks, seriously? So maybe Jim, comment on, is this a good summary of the types of risks that are there? And then we will shift into maybe talking about how we will more specifically address these.
Yeah, I mean, I think it's a good summary of the risk, and I'll quote Eric Brewer, who's a fellow at Google in general on this, whether it comes to risks or just bugs in software, which is we're super good at identifying bugs or risk. We're not that good at fixing them. This is the focus that we need to work on, and it is managing these risks. That unfortunately there is no quick fix. This will be a multi-year process to, in some cases, retire technical debt in critical parts of the open source supply chain that are critical to the internet. And in other cases, build up better practices within the end user community of software consumers to be able to remediate problems as they inevitably happen. I do think at a high level, there is a real sense of urgency, at least in the industry and also within certain parts of the end users of technology, particularly in critical infrastructure, power grids, utilities, and so transportation systems and so forth, due to government action. So the Biden administration's executive order last spring certainly motivated people to start working on these things. More recently, the FTC threatening legal action for organizations that don't remediate some of these real problems is an extremely high incentive for people to get their act together. Again, I want to come back to this concept of when I speak to open source developers, whether it's Linus Torvalds or the maintainer of a small JavaScript dependency, what they all can agree upon is that they love the ability to share code, to be able to work collectively to solve problems every single day. And if you destroy the trust in that process by having consistent and major security problems, you're sort of throwing the baby out with the bathwater here. And so I think that the crisis in confidence here doesn't necessarily come from within the developer community. I think developers understand how important it is to work together to create this complex software. It comes from outside of the developer community with consumers who are left remediating a lot of these security problems. And if we want to preserve all the goodness in open source, we've got to go manage these collective risks.
Wonderful, wonderful. So Randall, we'd love to get your view, like from the risk landscape here. Are these the right ones? Are there ones that are missing?
I mean, I think there's definitely a lot of things on here. There's obviously a lot of other types of risks as well.
Yep.
But I think this is a pretty good introduction to like what are just general things you should keep in mind. Again, like I'm really big personally on like looking at security not as like almost like a massive risk vector, like from the developer angle anyways, but more as just something to be conscious of. Because again, like you're never going to have perfectly secure software. I think a lot of the time people get really held up with the fact that we need this to be like 100% perfect and secure and everything. And the reality of the situation, of course, is like there's new vulnerabilities discovered all the time, right? And so like maybe you do a full security audit, you hire the best security audit firm in the world. Let's say you hire Latacora and you ask them to go through and analyze every line of code in your project manually, and you have the best security researchers in the world doing that. Well, it doesn't really matter if 2 weeks later a new vulnerability is found in one of these dependencies and it didn't exist 2 weeks ago when you did the audits. And so I think the really important thing to get across is like all those things you see on the slides there, the development stage, integration, deployment, post-deployment, all these different areas, they all need different tools and techniques and processes to be in place to, at the bare minimum, be able to identify when new things are discovered in your stuff and then alert you so that you can properly handle it. But yeah, I think this slide does a really good job of sort of summing up a lot of those areas to just be more conscious of. But don't let that scare you.
Yeah,
wonderful. Go ahead,
I would also add there that this does a good job of summing up sort of the lowest hanging fruit in terms of raising the baseline for security. Attackers exploit the easiest attack vector they can possibly find. I mean, if the door is left wide open, they're going to walk right in. And so I think what this illustrates is, an interesting, like if we just played a little game and tried to rank these in terms of, ease of exploit versus ease to fix, that would be an interesting way to essentially look at security. So, I mean, it's a good news, bad news thing in that I think the bad news right now is there's a need to significantly raise the bar here. Like, in the open source world, I think it's important to sort of look at ourselves and say, should package managers have, cryptographic signing? Should we ask, maintainers of critical projects and provide them with funding to take a secure coding class in order to, not make the kind of vulnerability mistakes that maybe Log4j would have made, and so on and so forth. So, this is where there is some good news at the same time, which is, when the bar is low, we can get some quick wins. And so I think when I look at a chart like this, I'm looking for where I can find quick wins in order to collectively raise our security baseline.
I would also.
Sorry, go ahead, Randall, please.
Sorry, Ajay. I was just going to add one thing, but like, Jim, you made a really great point, right? Like, what are the easiest things to catch right away? Like, so if you're watching this and you're not super familiar with security, like on the developer side anyways, one of the best resources you can look at is like this list called the OWASP top 10. And this is a list of like, what are the top 10 most common vulnerabilities that exists and that are found every year in like predominantly web applications, but it applies to more than just web applications. And so if you want to just take a look at that list, like the OWASP Foundation actually just published an updated list a couple months ago with their recommendations for the year of like, what are the top 10 things to be aware of? But that's a really good starting point. And there's a lot of tools out there. Like the OWASP project has great open source solutions. I'm sure BluBracket does this. I know Snyk does this. A lot of other places have tools as well. They can help you find and identify those types of issues in your projects like pretty easily. So there are some problems, I would say, in the software development world that have been like not completely solved, but there's enough good tooling out there where you can easily leverage other solutions to just like make your life easier. And then there's some things that are a lot harder. Like for example, one of the things listed on here in the development stage is flawed cryptography. Cryptography is like a very like niche subset of the security community, but it's incredibly important. And like those types of issues are really hard to identify, require a lot of expertise to use. And for things like that, you know, one of the best go-to answers that security people say all the time is like, don't roll your own cryptography, use existing vetted solutions, things like that. And I think the same is generally true for most of this development stuff. Like try to use existing vetted solutions that are healthy projects. That might mean projects where like they're actively maintained, you know, there's more than one maintainer, hopefully, you know, just pay attention to the things you're using and try to stick with things that are big and popular, because you're likely going to get more up-to-date stuff where security is more of a concern and things are updated more frequently. So just throwing that in there too.
Yeah, I would agree with that. I think one of the things that we're finding that's interesting, in a couple of weeks, we're going to be publishing a report on critical software in conjunction with Harvard University. And of the top 50 most critical application packages, these are non-operating system packages, things in Java, JavaScript, Python, and so forth. 36 of those are not hosted at foundations like the Linux Foundation or the Apache Software Foundation. And of those 36 projects, 80% of the code is written by 126 maintainers. Wow. I think it's important for us to be able to go and talk to those folks and provide them with an extra set of helping hands, to work with the security community, to teach them how to have security discussions with those developers in a way that's actually helpful, like not send them a bunch of indecipherable CVEs that they can't, that's very difficult to understand what to even do with those. But this is where, if we can do that and then show that that's happening in a reputation-based system, you know, to Randall's point, if you're using those projects, you're going to generally be a little bit better off. Scaling those to the longer tail of open source projects, which are widely used in a variety of critical infrastructure, is something that we also need to focus on. So, you know, I'm obviously shifting to the extreme left here in the upstream source code projects that are later downstream supported largely by vendors who provide technology services. But we need to focus on all of these layers in order to improve our collective security.
Yeah, I think this discussion is a great segue, especially you pointing out, Jim and Randall, what has the best bang for the buck? I mean, where can someone start? We do want to be a little bit prescriptive here. So there are some recommendations that are forming. What, you know, in terms of your mindset and what you've been talking about for the audience in general, if they were to looking for the best bang for the buck to be able to eliminate these in their internal as well as external code along the CI/CD's lifecycle prior to deployment and then into deployment, there are certain things in terms of corrective actions that can be taken. And, you know, let's say you guys had to put your feet to the fire and say, what are those top 3 or 4 things that can be done or should be done to be able to mitigate and eliminate these risks? How do these map to that based off of what you're saying? Is there anything from, and now we talked about the risks, now we're talking about a little bit more prescriptive on the recommendations. We've covered some of those in terms of just making this as part of the ethos of the organization, making this, put this good tools in the developers' hands to solve these problems early. But the other pieces, once you get beyond the development lifecycle, you get into CI/CD and into the deployment and production. Do these things make sense that are listed here? And maybe I'll allow you to, Randall, to comment on some of these and then hand it over to Jim to comment.
Yeah, so I'm going to comment on the last part of the question first, which is who should be responsible and accountable? And I'm going to give you 3 quick answers. So from the developer side, I think you should personally be responsible for the overall security posture of whatever it is you're building. So like you should be conscious of security when you're building things. You should do your own due diligence when you're importing new dependencies into your application. You should look them up, use tools to like help you vet those dependencies and make sure you're not, causing massive security problems for your organization. On the security side, if you're like an AppSec engineer or a security person working inside of a company, I think times are changing. Your job isn't to sort of like police the security of your organization necessarily. I think it's more your job nowadays is to enable your developers, your engineers, your DevOps practitioners to better build secure applications. Like how can you empower them by getting them tooling and processes and reporting environments where they don't need to come to you all the time for every little thing, and you don't have to continuously hound them to fix problems? Like, how do you build this more collaborative culture between your two groups? Then from the management perspective, if you're a manager or a leader of an organization, the thing you should really be focused on is how do we cultivate a culture at our organization where everyone thinks and cares about security? I think that's really important. Like there's, security champions programs that have become really popular in recent years for companies to run, which is essentially where, you have an executive sponsor like the CEO or the CTO or the CISO, whatever it is, who basically says, look, everyone, we care about security. And I would like to nominate a champion from each of our teams to sort of be like our official security person. And they can coordinate with our security team to learn about the new things coming out, learn about risks, and just provide training and better empower all of these teams to make security consciousness part of their overall mission. So just in terms of who's responsible and accountable, like that's how I see it from those 3 different angles. And I'll let Jim talk more about the other stuff here.
Yeah, I think all these recommendations are really good. I would add one additional, which is unfortunately a shortcoming of a lot of computer science programs in higher education. Software secure coding practices is just not a required course for almost all computer science programs that I'm aware of. If you could do one thing, and the Linux Foundation offers free secure coding practices courses. We also offer certificate programs, but just training developers on how to write secure code can really go a long way. Again, there are vulnerabilities that get inadvertently put that are just basically bugs in software that super smart security researchers are able to find. But there's also just a common set of mistakes that you can make when writing code that if you're aware of, you wouldn't do it. I mean, I'll give you an example, and who knows if the folks at the Log4j project would have caught this, but one of the parts of the vulnerability is explicitly called out in the secure coding class that we offer at the Linux Foundation, authored by David Wheeler. And who knows if they had taken that and maybe been able to have more resources to spend more time on that project, it would have reduced the risk of that vulnerability from happening. So if there was one additional thing I would add here, which is it's just get your developers trained on secure coding practices.
Also, I would like to just plug David Wheeler's course. I don't know if you can say that one more time, Jim, but I signed up for it and took it maybe 6 months ago or so, or maybe it was even more recently than that. And I thought it was really great. So if you're watching this, you're interested in security and you want to learn more about it, I highly recommend signing up and giving it a go.
Secure Software Development Fundamentals by David Wheeler, the Director of Supply Chain Security at the Linux Foundation.
Wonderful. That's great. So I'm going to hold your feet a little bit to the fire here as well, because we get this question quite a bit. I think everything you're saying makes complete sense. It's got to be built in from the earliest aspects of coding. In organizations that are more mature, I'll give you an example, right? So already there's all kinds of, as you mentioned earlier, technical debt. There's Git history. There's thousands, if not millions, of lines of code that are there that are now traversing from development into the CI/CD out into production. So organizations that we speak to are struggling a little bit about that accountability and that responsibility. Do you guys advocate or believe in a shared responsibility model where it cuts across development and goes into DevOps along that chain? Or do you think this should be, at least the accountability at some level should be rolling up into DevSecOps, DevOps, AppSec? Where does this fall? And the answer could be that it needs to be shared responsibility, and everyone should be held accountable. So maybe if you guys could address that in a real world organization, where will the buck stop? Where should it stop?
I mean, so typically, like, it depends on how the organization, like, I don't think there's necessarily a one size fits all answer, because organizations of different sizes and different structures, like within engineering and security, are just going to do it differently. I've seen it a number of different ways over the years, working with like a lot of real world companies. Usually I would say, like, if we're talking about like really big enterprise companies, the buck stops in the security department. So like as a part of engineering, or sometimes even as a parallel organization, you'll have your CISO and like AppSec engineers under them. You'll have, blue teamers, red teamers, et cetera. Everyone is working holistically to ensure the integrity and the security of the company's products. And so even though you might have a security champions program that is involving developers and operations people and everyone else, at the end of the day, the security teams are still mostly on the hook for ensuring that these things get done. I think that especially when you're talking about really big organizations, that model still makes a lot of sense, in the same way that back like 15 years ago when I was interning at Cisco or whatever, there was an operations team that was responsible for doing all the deployments. I think if you're looking into the future, maybe 5-10 years, that story is going to be very different, because I think by then there's going to be enough of this tooling and enough of this enablement materials for the developers that, again, all of this responsibility will be shifted left, and you'll see a lot more of the security responsibility being part of the engineering organization. But I would say that right now, yes, security teams are still the ones that are predominantly responsible for that stuff.
Wonderful. Jim, any comments on that?
I mean, I'm getting called into a lot more board meetings these days. I agree that the implementation of those policies should reside in the groups that Randall mentioned, but this is a CEO and board level responsibility. And I think it's important for leaders in industry and in government and society to recognize that, we all get tremendous value from all the different software systems that we use every day to, share knowledge, to be able to efficiently transact, financial systems, to more, even more impactful things like, creating a better smart grid. But the responsibility, I think, starts at the board and at senior management, who need to empower developers and security teams with the resources that they need to deal with this heavy responsibility. Because I can guarantee you that, if the FTC is going to, go and regulate a particular actor, they're probably not going to call the security team first. They're going to call the CEO.
Well, yeah, I think that makes a lot of sense. I think we're seeing that across the board, that this has now become a board level discussion. In one big way, that's incredibly important, because then, if it's getting that kind of visibility, these problems will hopefully get resolved. We're coming to the end of our session here, and I'm just going to put up the contact information for anyone to follow up with questions that they may have about how to solve some of these different problems and address them. But before we do that, it's been a great 50 odd minutes of discussion that we've had here, and to basically want to give you guys the ability to just summarize your thoughts. If you have to give one or two pieces of advice, I think you guys had some really good insight and very consistent in terms of what you were imparting. But let's say you have to give 2 pieces of insight or 3 pieces of insight to walk away from what we've just talked about. Randall, what would those be? What would be your final words in terms of what to think about?
I would say, security is important, but don't let the fear of doing a bad job of security stop you from taking action. The most important thing is get out there and take some action to just improve security. That could be as simple as instrumenting one tool into your workflow and just taking a look at those results like once a week. It doesn't have to be complicated. The main thing is like do something out there, and that will be better than today. And as long as you keep moving forward, you're going to leave your applications in a better state than they are today. And that's the thing that matters most.
Wonderful. Jim, your final words of wisdom?
Yeah, I think we, collectively as the software industry, as developers, as anybody who participates in the technology supply chain, it's important to reinstill confidence that, we can create secure systems. And, as my mom used to tell me, you got to eat your vegetables before you get to dessert. And unfortunately, we have not been eating our vegetables for a while in terms of supporting the security community, in terms of maintaining secure coding practices, in terms of remediating weaknesses and the distribution mechanisms of software. But the positive message is we can go fix those things. We are actively working on it. We need to collectively have resilience in order to do it so that we can get to dessert, which is creating super cool technology products and services that all of us know and love. And so, that's my single message is, let's come together as an industry, as an open source community to provide the resources to collectively meet this challenge.
Words of wisdom, truly. Jim, Randall, want to thank you so much for taking the time for speaking with us. As I mentioned, you can get in contact with any one of us, and we're more than happy to answer quite any questions you might have post our webinar. I think Cody's going to come on in a second, talk about how you can get access to the full recording of the webinar as well. And we're all committed, Linux Foundation, Sneak, BluBracket, to helping solve this problem at various points in the development and the software supply chain lifecycle. We have resources, we have free access to all our different resources, as well as in the case of Sneak and BluBracket, our software. We just want to help move the ball forward, as both Randall and Jim have talked about from a security standpoint. This is definitely a marathon, not a sprint. And I think Jim and Randall have done an amazing job at kind of conveying what those key risks are, the key principles to follow, and how we go about mitigating these risks to make the world safer, honestly, as it relates to software, since it's the underpinning of so much. So with that, thank you so much. Again, I'm Ajay Arora, and thank you for taking the time. Really appreciate it. I'll hand it back to Cody.
Outstanding, guys. Thank you so much for taking the time to be here, for having this discussion, putting together this presentation, and sharing your expertise, most importantly. To answer that question that we had in the Q&A, to access the on-demand recording, an email will go out shortly after we conclude this webinar with a link to access it. Feel free to watch as many times as you want, and please share it with your friends. So on to the 4 winners of our $25 Amazon gift card drawing. Our first winner is Jocelyn H. Our second winner is Angelica D. Our third winner is Corey G. And our fourth and final winner is Buenaventura B. So congratulations to the 4 of you. Keep an eye on your inbox to claim that gift card. And if you don't find that email, just check your spam folder. So Ajay, Jim, Randall, thanks so much for being here with us today. I'd like to extend our gratitude to BluBracket for sponsoring today's webinar. And my final thanks goes to you, our audience, for being here with us for the entirety of today's program. My name is Cody J. Brown, signing off. Have a great day, and please feel free to submit our post-webinar survey.